Compile your program. Here I am doing with an example program. After successful compilation, we need to generate the hex file. In the newer MATLAB X IDE versions, it may not see the hex file in the output folder. This can exported like mentioned here. Right-click on the project, select Projects, click on Export Hex, browse a location and save. Next step is to verify whether the USB COM is detected, from the device manager. Here I didn't plug the TKit to the USB port, let's do it. Plug in the power adapter, it's optional, the board can also be powered from the USB port. Limitation is that only 5B parts of the board will work. We can see that the bottom green LED, near to the USB port is blinking fastly, means that USB is not connected or enumerated at PC. Once enumerated successfully, the LED flashes slowly, and in Device Manager it can see that COM2 is assigned for port. Open the programmer, select the COM port, to check it's communicating with TKit by clicking the Check Device button, meantime click on the Reset button also. Then it show the success status. Next, to program the file, browse to our previously exported hex file location, then click on Right Device button, meanwhile click on the Reset button also. Programming starts. It may take time according to the program size. The programming app is designed to communicate with the controller on 19200 bps baud rate. In case while connecting the USB, if the enumeration fails, the check whether the USB device driver is loaded correctly. If the USB is detected correctly and while during the check device status at the programmer fails, then the reason may due to the false serial USB selection switch position at cell_SW4. After program completion, the device resets and ready to use. In this example I have loaded a menu-based demo program, in which most of the sections of this board functionality is utilized. Since most of the functionalities are multiplexed in the board due to the pin constraints of the microcontroller, please following the necessary instructions in the manual and schematic diagram. The appropriate selection of the dip switches should be followed, according to the manual. In this built-in ADC program utilizes the N5 pin at RE0. For testing, a jumper is connected in between this RE0 pin and a voltage pin, whose voltage can be varied by the R48V_offset potentiometer. Seven-segment display demo program. As mentioned earlier, since the LCD and 7-segment displays share STHE same pins, the cell switch positions are followed as per the manual. Programs are included as per the memory size limitation of the controller. The individual demo programs are also shared with the kit for further experimenting from your side. This simple addition program utilizes the LCD, matrix keypad functionalities. Thank you for watching this video. Hope it helps you to understand this kit's basic working. If you got any doubts, please feel free to mail to us.